morning children, welcome back to the video classes. In the previous video we solved 1.4. Now in this video we are going to solve 1.5 and 1.6. Okay, right. So 1.5, draw the free body diagram for the following charges as shown in figure. Okay, so for first one, A, the force F equal to mg which is acting in the downward direction. So F equal to mg which is acting in downward direction. Okay, so next one, the normal reaction force which is acting on the object in the upward direction. So it's normal reaction force. Okay, now it is the electrostatic force which is acting away. Okay, Fs. Now what is Kx? Is the spring force or spring constant K. The spring force is acting towards or opposite to the electrostatic force, that is spring force. Okay, so this is the free body diagram for the first one. Okay, now we can go to the second one. Okay, so a bomb with a positive charge is suspended and it makes a certain angle. Okay, the force which is acting, the positive charge attracted by the negative charge. Now the force is acting in the downward direction. Now this is the tensional force. Okay, so now this is the tensional force which is acting through that point. Okay, so this is the point where the bomb then which experiences a electrostatic force on the right hand side. Okay, this is the electrostatic force. Then the force which is acting towards the earth or weight F equal to mg, and this is the free body diagram for the second one. Okay, now we can go to the third one. Okay, so the electric field is always acting from positive to negative. Okay, now this is the negative charge. The negative charge is attracted towards the positive. Okay, now the electrostatic force is acting in the upward direction. Okay, now Q has some mass, then it attracted towards the center of the earth. So its weight is acting in the downward direction. So F equal to mg which is acting in the downward direction. Electrostatic force which is acting in the upward direction. And this is the free body diagram for the first question. Okay, now we can go to the second one. Consider an electron traveling with a speed of v0. Okay, so the initial velocity is v0 entering into a uniform electric field E vector. Okay, so E vector which is perpendicular to v0 as shown in figure. Ignoring the gravity, obtain the electron's acceleration. So first we are going to calculate the acceleration. So for that I want to go F equal to ma, F equal to E which has the negative or opposite direction. Now the LHS are equal, then automatically RHS are equal, then ma equal to minus EE. So A equal to minus EE by m. Okay, now what about the direction? Okay, so the velocity is taken along the x-axis. When it moves in the downward direction. So when it moves in the downward direction, it automatically moves in the y-axis. So negative sign. It shows that it moves in the negative or y dash axis. So what is the value of acceleration? Acceleration equal to minus EE by m into j cap. Why we are putting j cap? Because it moves along the y-axis. Okay. So second one, calculate the velocity. Okay. So how we can calculate velocity? That is v equal to u plus at. Okay. So what is u? U is the velocity, initial velocity. So initial velocity takes along the x-axis. So that for instead of u, we can write v0 I cap plus a. So what is the value of a? Minus EE by m into j cap into t. Okay, so how we can write v0 I cap plus into minus minus E by M into T into J cap. So thus we can calculate the velocity. Okay. Next one, the position as a function of time. Position as a function of time. Okay. So S equal to ut plus half at square. So S is the position. So it can taken as R. U is the velocity. So what is the initial velocity? V naught. So V naught I cap into T plus half into A. So what is the value of A? Minus E by M into J cap into T square. Okay. So V naught I cap plus into minus minus half E by M into T squared into J cap. So that is the value of the position of the electron. Okay. Now do you get it now? Do you any doubt? No doubt.